Okay, so this is called Big Motor Rebuild, and it's by far the biggest motor that I've ever had the opportunity to play with. It's a great big DC series wound traction motor from Forklift, that Forklift right there, which it's a Daewoo Doosan 6,000 pound capacity. That picked up at an auction, partly because it had a lithium battery in it, and I wanted the batteries, but I thought I would like to replace our propane forklift with electric anyway, and it looks like the previous owner was able to completely cook the brushes, melting parts of the brush holder. One of these brush holders is really toast. I can't remember which one. Is that the one? Can't even see very well through the camera. Oh, there. That's the brush holder that some of the brass is actually gone. So it's supposed to look like that. Ended up looking like that. The old brushes are, some of them are scorched. Some of them have quite a lot of pitting. At any rate, it was obvious that the motor needed new brush holder and new brushes. I was able to find those on eBay thanks to Nash Lift for a reasonable price on that, and on new bearings front and back. And now I've got it all apart and cleaned up. And now the challenge is to clean up this poor, sad-looking commutator. It's not disastrous, and like most of this forklift, it's got loads of life left in it, but I just feel like if I'm going to put new brushes in, I should clean this up. So I learned what I could from forums and YouTube, and now I'm going to put it in the lathe and turn a couple thou off the commutator and see how it comes out. Okay, so here's the motor armature set up in the lathe, and you can see the commutator. I've just touched off in one little zone. You can see the shiny strip vis-a-vis the tool, and I've tried to set it up according to seemingly good advice that I found online, that you really want it to run true to the bearing journal. And so I fitted the new bearing and then set up the steady rest to hold the bearing, and then centered it using a fixed center, and then put the live center in, and I've chucked it to in the 3-jaw chuck to the inner bearing journal on the drive end. So hoping for the best, and I'm not sure about feed rates, and so I'm going to go for as fine a feed rate as I can guess at, and turning rate. It's a relatively big diameter, so I'm going to go for, like, I don't know, 500, 700 RPM. I have no idea if that's correct. Maybe someone will inform me in the comments, but anyway, I'm going to do a first pass. If I totally screw it up, then I could, of course, take it to a competent motor rebuilder there's still enough thickness to fix it if I screw it up. So I don't have a proper tripod, so I'll try to get it running and then shoot a little bit as it traverses. So it looks like it's not taking off quite enough yet, which is fine with me. I'm going to run it again. So the result of that first pass is promising, but there's still a significant amount of pitting to remove in the section with the most wear. And then I'll obviously have to clean out the grooves between the comm bars, but it's looking pretty good, so I'll take another couple thou off and see how it looks then. Okay, so I did one more pass, or maybe two more passes. Took off another, I think, 0.02 to get to the bottom of the pitting, but I haven't really introduced much of a step here. You can see that. It's probably not going to come out, but I think I've got the brush area started a ways up here, so I'm not going to worry about getting into there too much. You can see in the grooves between the comm bars a fair bit of copper, and I was trying to pick them out with this, but it's a little bit tedious. And then I switched to, as recommended by various people, hacksaw blade, ground smooth so that it's got no perf or set. So it's a flat hacksaw blade, and then that running in the grooves gives this, for instance, is a groove that's been cleaned out in that one. So now I got 20 minutes of cleaning the grooves out, and then I gotta find some sandpaper that's ostensibly non-conducting and polish it up, but looks pretty darn promising for not leaving the farm. Okay, here's finished armature. The polishing and cleaning between the comm bars seems to have worked out pretty well. Edges are still a little bit imperfect in places, but ultimately I ran out of patience. My estimated 20-minute job took, I don't know, an hour, and then I had to have dinner and go to sleep. And so now it seems good enough for me. You can see a few scratch marks on the comm bars from where I slipped with the pick or the hacksaw, but I'm going to call that acceptable. And there's still a very few pits that were deeper than the amount I took off, but I'm going to call this good enough. And I've got the new brush holder mounted, so all the shiny new hardware. There's a pair of brushes that maybe you can see okay in the brush holder. Springs aren't yet in place, so and then inside the we gonna get that? So the field coils wrapped around their cores, and then the big flat section straps with the blue insulation on them are the field coil bus bars, and then each of the field coil bus bars comes up and just screws in along with one of the brushes, so you can see the connection to the field coils there. And then these are brush wear indicators that are all chained up together, and they run out to where the connection studs. The outside of the case, the motor has armature 1 and 2 that go to the brush holder, and then the other end, field 1 and 2, S1, S2 down there, that allow connection of the field so that you can change the direction by inverting between A1 and 2 and S1 and S2. And then this is the connection for the brush wear indicator. And the last thing is there's a thermocouple tucked into the case here for a temperature sensor. And then there's a plug that I only noticed after getting it all apart. There's a dummy bolt here, and that's actually a hoisting point. So, you know, having noticed it, I might as well use it for the reinstall. So those are the brush springs, and now it's time to stick it all back together and then put it back in the lift. Now the motor is all back together. Excuse me. The reassembly went fine. It's moderately heavy, but in fact I tossed it on a scale and it was 80 some odd kilos, so pretty much bang on 200 pounds once it was all put together. But everything went together smoothly, and it spins really nicely. No appreciable resistance or sounds. I've run it a little bit on this test setup, and the commutator is just starting to make stripes adjacent to the corners of the two brushes that you can sort of see. Can't quite get the brush angle there. You can just see where the two brushes meet in the middle and the ends. And it stays well away from the step that I had to machine. And anyway, it all looks good. I set it up and tried to just clamp it. So it's series, so I'm only running it at 12 volts, and I'm having to just pulse it because I don't want it to overspeed. But I tried with some chintzy little cables initially, and ultimately, after melting one small connection, I realized it's really drawing quite a lot of current, just kept moving. And it turns out that it's drawing about, when I get it spinning, upwards of 600 amps when it starts. So that's a lot of inrush current. So I gave it a little contactor and then wired that up, and so when I energize the contactor here, get motor movement. Yeah, sounds pretty good to me. I don't really know how much noise this motor is supposed to make, but that sounds fine to me. I'm pretty happy. So yeah, guess next step is putting it back in the forklift. Anyway.